Hi everyone, this is Teacher Jules once again and welcome to another lecture video about plane trigonometry. Now previously we talked about the right triangle and how to solve for the missing side using the Pythagorean theorem. Now in this video we're going to talk about the 6 trigonometric ratios. Specifically, we are going to define the 6 trigonometric ratios of an acute angle in terms of the right triangle and also evaluate trigonometric ratios in terms or using right triangle. Recall that a right triangle is a triangle having a 90-degree angle, or one of its angle is a right angle, and the side opposite to that right angle is called the hypotenuse. Let's consider one of the acute angle and let's denote this angle as angle theta. The side opposite angle theta is what we so-called as the opposite side, and the side next to angle theta is what we so-called as the adjacent side. Now try to remember these terms because these terms are very important as we define the 6 trigonometric ratios. To easily remember the 6 trigonometric functions and its corresponding ratios, let us use the acronym SOH-CAH-TOA. SOH-CAH-TOA. SOH stands for the sine function, CAH stands for the cosine function, and the TOA stands for the tangent function. Again, SOH stands for the sine function, which is equal to opposite over the hypotenuse, or it is represented by sin or sin theta. CAH stands for the cosine function, which is equal to adjacent over the hypotenuse, or it is represented by cos or cos theta. And TOA stands for the tangent function, which is equal to opposite over the adjacent, or it is also represented by tan or tan theta. Now, we had already defined 3 out of the 6 trigonometric functions, and the remaining 3 functions is so easy to identify or to determine once you remember the acronym SOH-CAH-TOA, because they are just the reciprocal of sine, cosine, and tangent function, respectively. And when we say reciprocal, these are mathematical expressions or functions so related to one another that their product is 1. The reciprocal is usually the flip of the fraction or the ratio. So for instance, we have there 1/2. The reciprocal of 1/2 is 2 over 1. The reciprocal of sine function is the cosecant function. The reciprocal of the cosine function is the secant function, and the reciprocal of the tangent function is the cotangent function. Cosecant is denoted by CSC theta, while secant theta is denoted by sec theta or SEC theta, and the cotangent is denoted by cot or COT theta. Now, since cosecant theta or cosecant function is the reciprocal of sine function, and sine function is equal to opposite over hypotenuse, therefore cosecant theta is equal to hypotenuse over the opposite. Secant function is the reciprocal of cosine function, and cosine function is equal to adjacent over the hypotenuse, therefore secant function or secant theta is equal to hypotenuse over the adjacent. And cotangent is the reciprocal of tangent function, then cotangent theta is equal to adjacent over the opposite. And there we have the 6 trigonometric ratios or the trigonometric functions. We have sine theta, which is equal to opposite over the hypotenuse. Cosine theta is equal to adjacent over the hypotenuse. Tangent theta is equal to opposite over the adjacent. Cosecant theta is equal to hypotenuse over the opposite. The secant theta is equal to the hypotenuse over adjacent, and cotangent theta is equal to adjacent over the opposite. Now, since we already know now what are the six trigonometric ratios and its formula, let us try to use this one in these following examples. In this right triangle, we have right triangle with sides 5, 12, and 13. And since our theta is in here, the opposite side of theta is 12, the adjacent side of our angle theta is 5, and the hypotenuse is 13. Now, what we're going to do is to find the six trigonometric ratios. Let's start with sine theta. Since sine theta is equal to opposite over hypotenuse, and the opposite is equal to 12, and hypotenuse is equal to 13, therefore, sine theta is equal to 12 over 13. Next is the cosine theta. Since cosine theta is equal to adjacent over hypotenuse, and the adjacent is 5 and hypotenuse is equal to 13, therefore cosine theta is equal to 5 over 13. Now, tangent theta is equal to opposite over the adjacent, and the opposite side is equal to 12, and the adjacent side is equal to 5. Therefore, tangent theta is equal to 12 over 5. Next is the cosecant theta. Again, cosecant theta is equal to hypotenuse over opposite, and hypotenuse is equal to 13, and opposite side is equal to 12. Therefore, our cosecant theta is equal to 13 over 12. Next is our secant theta, and secant theta is equal to hypotenuse over the adjacent, and the hypotenuse is equal to 13, and the adjacent side is equal to 5. Therefore, our secant theta is 13 over 5. And the last one, we have the cotangent theta. Cotangent theta is equal to adjacent over opposite, and adjacent side is equal to 5, opposite side is equal to 12. Therefore, our cotangent theta is equal to 5 over 12. And there you have it. We have already found the six trigonometric ratios. And now let us try to have this another example. Now, if you want to answer ahead, you can do so. Just pause this video if you want more time. And let us try to compare your answer with our answer later after this 10 seconds. So, timer starts now. Okay, time is up. So first thing we're going to do is to name all the sides. Having here angle theta, the opposite side of angle theta is equal to 2. The adjacent side of angle theta is equal to 1. And the hypotenuse is equal to square root of 5. Now, let us start now to solve for the six trigonometric ratios, and starting with sine theta. Sine theta is equal to opposite over hypotenuse, and the opposite side is 2, and the hypotenuse is square root of 5. Since in the rule of real number, there should be no square root or radical sign in the denominator, we should eliminate that square root by multiplying it by 1 and renaming 1 by square root of 5 over square root of 5. So 2 square root of 5 is equal to 2 square root of 5, and square root of 5 times square root of 5 is equal to 5. Therefore, sine theta is equal to 2 square root of 5 over 5. And now let's have the cosine theta. Cosine theta is equal to adjacent over the hypotenuse, and adjacent side is equal to 1, and hypotenuse is equal to square root of 5. Now this time again we have a radical sign in the denominator, so multiply it again by square root of 5 over square root of 5, and we have here now cosine theta is equal to square root of 5 over 5. Next is tangent theta. Tangent theta is equal to opposite over the adjacent side, and the opposite is 2, adjacent is 1. Therefore, tangent theta is equal to 2. Next is the cosecant theta. Cosine theta is the reciprocal of sine theta. Therefore, we have square root of 5 over 2. Secant theta is the adjacent or the reciprocal of cosine theta. So, therefore, we have here now secant theta is equal to square root of 5 over 1, or we have square root of 5. And the cotangent theta is the reciprocal of tangent. Since tangent is 2 over 1, therefore, cotangent theta is equal to 1 over 2. And there we have it. We have now the 6 trigonometric ratios. And that's all for this lecture videos about the 6 trigonometric ratios. And if you have some questions, feel free to write it in the comment section or message me directly. Thank you.